Alright, this is WAEC Chemistry Practical Alternative A 2025. I believe A is sure. Alright, let's clearly look at the titration aspect of WAEC Chemistry Practical 2025. Let's start with the yellow paper. An acid given, this time is hydrochloric acid, which is 8.6 cmq to be dissolved in 1000 cmq of water. That's 1 dmq. All right, and the base given is sodium hydrogen trioxocarbonates 4 of 8.0 gram. How to calculate the expected titer value? I'll be showing you this video on how to calculate the expected value. Newbie, new teacher, tutors, student, you don't need this aspect. But if you're a tutor and you don't know how to calculate the expected value, join me. Let me quickly show you how to do that. Now, we're going to be using what is called dilution factor, which is C1V1 equals to C2V2. Okay, from your stock value, you are going to be having the concentration of the hydrochloric acid to be 11.6 mol per dmq, which is the standard value from the stock preparation in your lab. And your volume given is 8.6 cm given from the yellow paper of hydrochloric acid. Now, and our final concentration is what we are looking for, which is C2. Final volume will be 1000 cmq. Quickly, let's dive into it, the calculation. So let's substitute accordingly. 11.6 multiplied by 8.6 equals to C2 multiplied by 1000. Can you see that there? Can you see that? All right. So when you make the C2 the sort of formula, we're going to be having our final answer to be 0.0998 mol per dmq of the acid. All right, let's look at the molar mass for sodium hydrogen trioxocarbonate, which is going to be 23 plus 1 plus 12, 16 times 3. All the molar mass will give us what? 84 gram per mole. Remember, your unit is very, very important when you're calculating for chemistry practical. Okay, now let's use conc of B in mole per dmq, conc of B in gram per dmq to be able to get our conc of B in mole per dmq. All right, let's substitute respectively. We have 8 gram divided by 84. That will give us 0.0952. That's mole per dmq of our what? Of our base. So let's use from the balanced chemical equation we have hydrochloric acid plus NaHCO3 going to give us the product of sodium chloride plus water and plus libration of carbon 4 oxide. That means the ratio of our acid to base is going to be 1 ratio what? 1 ratio 1. Did you get that? So using the formula, we have kappa over CBV equals to Na over Nb. So that means we have a 1 ratio 1 of acid to base. So let's look at what we have. We have our Ca, Va, Cb, Vb, Na, and Nb. So when we substitute the respective value given there, we are going to have a volume of acid at the end of the day to be what? 23.85. So this is the calculated titer value for this titration. It is the calculated titer value because of experimental error. Some people might get higher, some people might get lower, depending. But this is the calculated. So this is basically for tutor, a teacher, lecturer that doesn't know how to approach titration without performing the experiment in the chemistry. You can titrate it. So let's look at basically 5 examples. We're showing you 5 examples on how WAEC can test you as a student in this practical 2025 titration. Let's quickly dive in together. If you're yet to subscribe to this channel, please quickly do that. Okay, give it a thumbs up and make sure you give the like button. All right, let's dive in titration. Let's look at the first question. A is 0.01 mol per dmq of hydrochloric acid, while B is a solution containing 15.0 gram per dmq of a mixture of potassium chloride and sodium hydrogen trioxocarbonates. Okay, put A into the burette and titrate it against 20 cmq or 25 cmq portion of B using methyl orange as indicator. This one is specifically indicated in the yellow paper. Repeat the titration to obtain a consistent titer value. Tabulate your burette reading and calculate the average volume of A that you use. So these are the parameters that the expected question on that particular day. This is my table prepared. I prepared this table based on the calculated value of my VA. Now, I'm going to be using the first and the second word, the first and the second value to be able to arrive at the 23.8 CMQ, which serve as my volume of my acid. So let's quickly dive into the solution of the question. Remember, student, that your table must be as neat as possible. This table in WAEC carry 10 marks. The analysis here is 4 marks. These are 4 marks. This is another 4 marks. Okay, 4 plus 4 give you 8. This is 1 mark. This is another 1 mark. Give you what? 10 marks. Well, please take notes, students, so that you don't make mistake. If you cancel anything on the table, of course, as an examiner, you are going to deduct your mark. 2 marks will be deducted and 4 marks will be deducted all together. So make sure you don't cancel. Make sure your value are concordant. What I mean by concordance is the range of your value of the difference between the range of your value must not be more than plus or minus 0.2. WAEC is plus or minus 0.15, NECO plus or minus 0.2. I used to give my students plus or minus 0.1. So it's better you go with my student because we are making wave in my school. Let's dive in. From the result and the information provided, calculate. Number 1, let's calculate the concentration of NaHCO3 in mole per DMQ. Number 2, mass of NaHCO3 in B in gram per DMQ, and the percentage by mass of NaHCO3 in the mixture. All right, our mass of KCl also in the mixture. So these are what we are expected to calculate. Let's dive in. Let's calculate the cohesion of NaH in B first. So what are we going to use? Let's use Kavana. Using of Kavana, check your parameters quickly. You can see my own parameters there. I hope students, I hope you are working around the way of also working it. So just for us to substitute the value, when we substitute, we are going to be looking for making B the subject of formula. And when we do that, we are going to have our final answer to be what? To be 0.0954 mole per DMQ. Student, take notes. The moment you are dealing with mole per DMQ, it must be 3 significant figures. Did you get that? It must always be 3 significant figures. And remember this ratio, WAEC will give you 1 mark if you arrange this ratio the way it is arranged. So follow me. I'm an examiner. I mark WAEC on a red. So I'll give you the best thing that you need on this paragraph. So let's go to number 2. Number 2, we have mass of NaH in gram per DMQ. So we are going to be using formula. First of all, let's calculate our molar mass. It will be 23 plus 1 plus 12, 16 times 3, everything giving us 84 gram per mole. Remember, anytime you are calculating molar mass, you must use your unit to be gram per mole. Please take notes. You must use your unit to be what? Gram per mole. So let's use that formula. So we are going to have our 0.095 gram mole per DMQ multiplied by 84, which gives us 8.01 gram per DMQ of our B. Did you get about that before me? All right, let's proceed to the third one. I want to calculate the percentage by mass of sodium hydrogen transfer in the mixture. Remember, we have a mixture of NaHCO3 and KCl. So let's calculate the percentage. Percentage is going to be the value of our NaHCO3 8.01 multiplied by what? 100 divided by the total number of the mixture given, which is 15. So the percentage is going to be 53.3% of NaHCO3. All right, what is now going to be the mass of the KCl in the mixture? That's very simple. It's just to minus the total from the total value of the mixture is 15 gram minus the value of NaHCO3, that's 8.01. All right, final answer, you're going to get something about 7.01 of KCl. Did you get that before me? All right, let's look at the question number 2. A is a solution of HCl containing 4.82 gram per DMQ, while B is a solution of XHCO3 containing 10.6 gram per DMQ. Of course, go through the same route, put it into the burette and titrate it again 2025 using meteorology as indicator. And we'll have our titration the way it was for the first experiment because we are using calculated titral value. All right, let's look at the solution. From the result and the information provided above, calculate on the question of A in mole per DMQ. How do we approach that? The first thing is to calculate the cohesion of B mole per DMQ and molar mass of XHCO3. So let's quickly approach that from a balance. This is our balanced chemical equation. So let's quickly approach that. Our solution is going to be cohesion of A in mole per DMQ, which is when we use cohesion of A mole per DMQ equals to cohesion of A in gram per DMQ over molar what? Over molar mass. Our formula is this, and we're going to be using 4.82 divided by 36 point what? 0.5. So our final answer is 0.132 mole per dmq of A. Remember, our molar mass has been given to 36.5, so we don't need to calculate it again. So, question number 2 quickly. Question number 2 is a concentration of B in mole per dmq. Here we are going to be using Cavana, and when we use Cava, we look at our parameters quickly, then we substitute the respective value inside the formula and make B sort of formula. Then we have our concentration of B to be 0.126 mole per dmq. The next thing is to calculate the molar mass of XHCO3. So we're going to using our formula concentration of B in mole per dmq, concentration of B in gram per dmq over molar mass. We are looking for the molar mass, so the value given is 10.6 gram of XHCO3 has been given, divided by the value we obtain from CB, which give us 84.14 gram per mole. Remember, I told you your unit for molar mass is always gram per mole. Please take note when writing exam on Tuesday so that your mark will not be deducted or reduced by the examiner. Okay, let's go to question number 3 quickly. A is a solution containing 1.04 gram of HCl per 500 of solution. All right, while B was prepared by diluting 50 cm³ of saturated solution of NaHCO3 at room temperature to 1000 cm³. So put into the burette and titrate the same procedure for titration, and our balance equation is also involved. But this time around, let's look at whether there will be a twist to this question or not. Look at our table of value, very neatly arranged. Please make sure you arrange yours on Tuesday so that you can have your full 10 marks. It's free of charge. I used to tell my students this marks is a free of charge mark. So let's look at the question, expected question. Question of A mole per dmq, question of B mole per dmq, solubility of NaHCO3 mole per dmq. Do you know how to calculate that? And volume of carbon dioxide that will be liberated from a balanced chemical equation in 1 dmq at STP. Wow. Now, number one, you all know how to calculate a conversion in mole per dmq. But this time around, there's a little twist because always you were giving the value in gram in dmq. But now we are giving in 500 dmq. So you are expected to convert 1.04 gram, okay, 1.04 gram in 500 mq to what? To 1000 cm, which is the standard. So when you do that, you are going to be having 2.08 gram per dmq of A. All right. After then, you have to be able to convert your 2.08 to what? To mole per dmq by first of all calculating the molar mass of hydrochloric acid 1 plus 35.5 will give you 36.5 gram per mole. So when you substitute correctly, all right, you're going to have 0.0570 mole per dmq of the acid used. Did you get that before me? Okay, let's go to question number 2. Let's calculate the concentration of B in mole per dmq. Of course, you're going to be using Cava. If you don't know how to use this formula, please learn it because it's a formula that you cannot escape under titration. All right, let's look at the analysis. Of course, you're supposed to know your CA is 0.0570, your CB, your VB, which is our constant value we are using now, is 23.85. Then make your CB sort of a formula. Then you are going to have 0.0544 more per DMQ as our final answer. Did you get that before me? So let's look at question number 3. Solubility of NaHCO3 in mole per DMQ. In this method, I will be using dilution factor. My dilution factor is C1V1 and C2V2. So I'll be using dilution factor to be able to approach this question. 0.0544 mole per DMQ is the mole per DMQ obtained from NaHCO3 multiplied by my 1000, which is the standard CMQ. Okay, I'm looking for my C, and this one is given 50 cm is given from the question. So I'm going to have the solubility of NaHCO3 to be what? 1.08 mole per dmq. All right. Question number 3 says volume of CO2 that will be liberated from 1 dmq of B if the titration were carried out at STP. What it means that at STP, your volume is going to be 22.4. All right, I'm going to first of all convert my mole per dmq to mole. That's why I'm using that formula that says N equals to CV over 1000. N is equal to CV over 1000. That's the formula I'm using. That's the formula I used to calculate the mole per dmq of the reason why I'm doing that is I want to be using the equation, and our equation has to do with mole. So 1 mole of NaH from the balanced chemical equation will produce 22.4 dmq of gas that was liberated, which is CO2. Of course, the number of mole I have now is 0.0544 mole. Now will produce X. So when I do that calculation and I cross multiply, I'm going to have 1.22 dmq of NaHCO3. Are you following? MC is so sweet. Let's quickly dive into number 4 questions. A is a solution of hydrochloric acid, and B contain 2.45 gram of anhydrous sodium hydrogen trioxocarbonates 4 in 250 cm. Remember, it's not in dm cube now. So of course there's another twist here that you need to learn. Put it into the burette and titrate against 20 or 25. In my own school I use 25. That's why you see me using my VB to be 25. Your own school might use 20. Is also the same. Nobody will penalize you for that. Okay, our table of value is the same thing we are using all along, especially for the purpose of this video and for the purpose of this titration. Yours might not be like this, so don't panic. The examiner, the WAEC, marks your work based on your school. So your teacher, your tutor, we are going to prepare a report against that. So let's look at question number 1 now. From the result and the information provided above, calculate what the condition of B mole per dmq, condition of A mole per dmq, condition of A in gram per dmq, and volume of gas involved in the reaction at STB. Look at the previous question. So let's look if there's any twist concerning this question. Concept of B in mole per dmq, we're going to also convert 2.45 gram in 250. Okay, to what? To 1000. Okay, you just multiply it and do the same thing. Then you have 9.8 gram per dmq of B. So we are going to be introducing that formula that say conking mole per dmq equals to conking gram per dmq over molar mass. By now you should know how to calculate the molar mass. I should remember I told you that anytime you are calculating molar mass, is your unit is gram per mole. Very, very important. 1 mark is not a joke when it comes to chemistry, so don't play. Question of B mole per dm is 9.8 divided by 84, will give us 0.117 mole per dmq of B. Next, we look at question of A in mole per dmq. So we have Kaba. Okay. Question of B in mole per dm is 9.8 divided by 84, which give us 0.117 mole per dmq. Don't play. So let's look at question number 2, which is question of A mole per dmq, which is we're going to be using Kava. Remember your mole ratio 1:1, then substitute respectively each values. Then you have your Ca to be 0.122 mole per dmq. Hope I'm not too fast in teaching. Hope you are enjoying it. So let's look at the third one. Conversion of A in Conversion of A in gram per dmq. We are going to be converting our mole per dmq to gram per dmq. So we have to calculate our molar mass. By now you should know how to calculate the molar mass for HCl, which is 36.5 gram per mole. So let's use our formula. You have conking mole per dmq is equal to conking mole per dmq over molar mass. Then we substitute the value respectively. Then we have our final answer to be what? 4.48 gram per dmq. Volume of a gas involved at the reaction at STP, of course, is the same thing. N is close towards CV over 1000. So you are converting the mole per dmq to mole. That's why you are using this formula. Then the same thing from the balanced chemical equation, 1 mole of NaH produces 22.4 dmq, while 0.11 mole of NaH produce X. The final answer will now be 2.6 gram per dmq. The last question I'm going to be discussing is question number 5. A is a solution of 0.55 mole per dmq. B is a solution containing 0.0398 mole per dmq of trioxocarbonates 4. Imagine in the yellow paper we are giving HCl and NaHCO3. But in this question, the examiner is not looking at, the examiner is going to give you a kind of twist to the question. Okay, as a smart student, you are not expected to be exposed to the acid and base. Please take note. So don't go and write a balanced chemical equation here because you are not giving anything of such. So put A into the burette and titrate against the same procedure. Then you have your table of value, which is what we have been using at that 23.85. Let's look at the question, expected question from this particular question. Number one, we say number of moles of acid in average titer, number of mole of trioxocarbonate in the volume of B pipetted, mole ratio of acid to base, given that B contains 7.2 grams of additive trioxocarbonate. 4, calculate the concentration of anhydrous in salt B and molar mass of salt in gram per dmq, and finally percentage of waters of hydration in B. In other words, percentage of crystallization. Looking at all these questions, you see that there is no balanced chemical equation. How do you approach it? It's another twist to chemistry. So let me quickly explain how to do that to you. Quickly. First of all, let's look at the number of mole of acid in average data. The formula to be used is conc of A mole per dmq times volume over 1000. Of course, you have been giving your conc of A mole per dmq, which is 0.0500 multiplied by 23.8, which is the average volume of acid that we have been using, divided by 1000. So our final answer is 0.0119 moles of A. Please take note, moles of A. Let's number of mole of B of trioxocarbonate 4 in the volume pipetted is amount in mole, use the same formula, but this time around it's going to be the value of B, which is 0.0398 multiplied by 25. 25 is the volume of my pipette. In your school, if you are using 20, you are going to use multiply by 20 divided by 1000. So I have 0.000995 moles of B. The next thing is for me to calculate my mole ratio of acid to base. So I'm bringing the value of A and bringing the value of B together, ratio. But the next thing, the twist is I'm going to divide by what? By the smallest. So which one is smaller out of these two? I have 0.00955. So when I do that, I'm going to have 1:1. What idea is this one giving us? Giving me my acid and my base joined together, give me 1:1. Did you get that? Yeah, I know you are smart. So let's look at the next question B. Given that B contains 7.2 grams of hydrated trioxocarbonates, for calculate the concentration of anhydrous salt in B in gram per dmq. Molar mass of salt in B is 84 grams per mole. Concentration of B in mole per dmq is conc of B mole per dmq over molar mass. So when you substitute that value, you have 0.0398 multiplied by 84 is going to give you 3.34 grams of what? Of B. Look at it here. So when we do that, let's now calculate the percentage of water oxidation. So the value, which is 7.2 minus 3.34, now give us 3.86. So the percentage of water oxidation will now be 3.86 all over the total, which is 7.2 multiplied by 100. Then we have 53.6. Video. Kindly subscribe to this video. See you in my next video. Bye for now. Thank you.